guys, welcome back to TechDose, and in this video we will look at count ways to build good strings problem, which is from Leetcode number 2466. Let's now look at the problem statement. In this problem, given the integers 0, 1, low and high, we can construct a string by starting with an empty string and then at each step perform either of the following operations. We can append the character 0 0 times, or we can append the character 1 1 times, and this can be performed any number of times. A good string is a string constructed by the above process having a length between the low and high inclusive of this range. Return the number of different good strings that can be constructed satisfying these properties, and since the answer can be very large, take it modulo 10 to the power 9 plus 7. Now let's look at the constraint before we look at an example. Now in this particular problem, the low and high range is 10 to the power of 5. So the expected time complexity will be n, or n log n, or n root n, not more than that. Okay, now let's look at an example. Let's take that a low value to be 2 and the high value to be 3 and the 0 to be 1 and the 1 to be 2. The 0 equals to 1 means that we can place 1 0 at a time, and 1 equals to 2 means that we can place 2 ones minimum at a time. You cannot place a single one, it is not allowed, because 1 is defining the size of the subarray when you are building the string. Okay, now the goal here is to count the good strings. So we should always make sure that the length of a good string should be within the range of low to high, and we can only append the zeros 0 number of times and append ones 1 number of times. Okay, now if I want to construct a string out of it, then I can place 0 one time and I will have a string 0. But is it a good string? Now the length of this 0 must be in the range of low and high inclusive. So it is not in the range of 2 and 3, so this is not a good string. But if I append 0 2 times, then will this be a good string? Yes, because it is within the range of low to high. It is of length 2. Now if I place 0 3 times, then will it be a good string? Yes, it will be a good string. It is in the range of 2 to 3. If I place 0 4 times, will it be a good string? It will not be a good string, because it is outside of the range of high, and therefore any further length beyond this 4 is never going to be a good string. So we need to confine our results within the range of 2 and 3. If you look at it, I have already constructed the good string 0 0 1 1, 0 1 1, 1 0 and 0 0. Now you cannot construct a 1 because the one subarray is minimum size 2, so you can take ones only in pairs. Okay, so if you take, let's say, 2 pairs of ones, then in this case the size will be 4, and so this will not be a good string. But if you take 1 pair of 1, then this will be a good string because it is in the range of 2 to 3. Similarly, you can take 0 followed by 2 ones, or 1 1 followed by 0, and these all will be good strings, right? So this is how you can try all possible combination in order to form the good strings, right? So we will see the solution for all possibilities in using recursion in some time, and we will do the analysis of time and space complexity as well. So I will not tell you the solution right now. The observation that we can make from this problem is count all the strings in the length of low and high. So you will always be starting at length 0, and you can place 0 0 number of times and 1 1 number of time. You can keep on building the string, and as soon as you end up with a string length, let's say in the range of low and high, then this will be added as +1 in your count of number of good string. But we will not stop here. If we can extend, let's say we add 0 number of 0 and we go to another new string s1, then if this s1 is also lying between this low and high, then I will also do a +1 for this s1, and from this s, if I add, let's say one number of times, then if I end up with a string, let's say s2, then for this as well we will be doing +1 because it is also in the range of low and high. And again this s1 can be extended by adding zeros and ones, and if it again ends up to be within the range of low and high, then I will do +1 and +1 for all of them, right? So the second point is we will extend the good string if possible to make another good string. Okay, so having seen these observations, whenever we are at a string position, we have to make one of the two choices, whether I will include the subarray of 0 or I will include the subarray of 1. So if I include the subarray of 0, then you know that 0 has to be added 0 number of times and 1 has to be added 1 number of times. So being at position I, if I add 0 number of times, then I will go to a new position which is I plus 0, because I plus 0, I plus 1, I plus 2 and so on, I plus 0 minus 1 will all be containing the zeros which we are filling up. So from I to I plus 0 minus 1, everything will be included by the subarray size 0, and so the next jump will be to I plus 0. And if you include ones from I, then all will be ones, and we will be going to the next position from where we can start filling up, and that position will be I plus the 1 subarray size. Okay, so these are the two choices. Being at a position, we can choose to fill up with zeros, or we choose to fill up with ones, right? So the recursion tree diagram will be a binary tree because we have two choices per position. Okay, so having understood all these things, let's now try to solve this problem by recursion. Now in this recursion problem, we will be taking the low value equals to 2, high value equals to 3, and we will be taking 0 and 1 equals 1 and 2, right? So I have already pre-drawn the recursion tree diagram, so let's try to understand this. We will always be starting with position 0 because my string will be empty. Okay, so side by side I will be showing you by building the string, but in the code you will not find the string because we don't actually need to build the string, we just need to count the number of ways. So I will be showing you the string just for your understanding. So at position 0, we can try to actually choose to go with zeros or ones. So let's say that we will be placing zeros. How many times I have to place zeros? Minimum 1 time. So if I do that, then from position 0, where will I go? I will go to position 1. So at position 0, I will place a 0. So my current string will be containing 0. Okay, and I am at position 1. Now at this particular position, we have to always check whether we are in the range of 2 to 3 inclusive range. But then 1 is outside of the range. Therefore, this is not a good string. This single 0 is not a good string. So from here, again, being at position 1, I have two choices. Whether I go with the zeros or I go with the ones. So if I happen to place zeros, then how many minimum zeros I can place? 1. So if I do that, then I will be forming my string to double 0, right? Appending a 0 after this 0. And my position will be 2. Now this 2 is within the range of 2 to 3. So this is a good string, right? This particular string is a good string. Therefore, it will contribute to count 1 plus whatever it gets by including zeros further and whatever it gets by including ones further, right? So all these will be added. Now let's explore if we are adding zeros, then what happens? So at position 2, if you add zeros, minimum you have to add 1 0. So your string will be 000. Okay, and we are at position 3. So is this position valid? I mean the size is valid? Yes. You will see that this 3 is actually within the range of 2 to 3. So this is valid. So what we will do is we will add a count 1 for it, and then whatever number of count I get by including further zeros and whatever number of count I get by including further ones. This is with the logic what we have previously understood, that even if a string is within the range of low and high, maybe further addition of zeros and ones will also lead to new strings which are also in the range of low to high. So we have to also account for those, right? So that is what we will be doing here. Okay. Now when we go by adding zeros after this position 3, we will be adding 1 0, and therefore we will be going to position 4. At this particular position, this is outside of the high range, and therefore I will not explore to further larger heights because they will never be good if 4 is not good. So this 4 will be returning a count 0. So 0 will be added here. And if you go for the ones inclusion at 3, then the one subarray size is 2. So from position 3, I will go to minimum 5, and since 5 is also outside of range of 3, so this will also be returning 0. So what is the total count when you were at position 3? When you were at position 3, then you had the string 0 0 0, and this was position equals to 3. This is 0 1 2 and 3. So at this particular index 3, we have a total count of 1 plus 0 plus 0. So this will be returning a value 1. So 1 will be added here, right? And now at position 2, we can go with the ones addition 2 times. So I'll go to position 4, and this is also out of bound. So this will be returning 0. Okay. So at position 2, how many total count did we get? 1 plus 0. So 2. So this will be returning a value 2. Okay. Now a string of length 1 was not good, and therefore we will not be adding 1 for it, but whatever is returned by including zeros, I will be keeping track of it 2 plus whatever is returned by including the ones. So if you go with the ones addition at position 1, which is having just string 0, then 2 ones will be added. And if you do that, then you go to position 3 and your string will be 0 1 1. Okay. At this position 3, we have already seen that if you are processing further from position 3, no matter what is the string on the left hand side, I don't actually care about whether I have added zeros or I have added ones or what was the string. Was it 0 1 1 or 1 1 0? It does not matter. What matters is the length. Okay, because whatever string we are creating is definitely by the rules, whether we are adding 0 number of zeros or 1 number of ones, right? So since the string is always following the rule, therefore the entire concept is about the length. The length should be within the range of low and high. So in this particular case, you will see that this 3 and this 3 are the exact same problem. Okay, so if I can just briefly define what will be a problem or a sub problem, then you can go with this 000, and then you can build your further string on the right hand side, or you can go with 110 and you can form further string on the right hand side. These two will be the same sub problems, will be treated as the same sub problem. The sub problem will always be in terms of position, or you can say in terms of current length of the string that you have already built, because this problem is all about counting the number of ways, right? It is not containing any other variable which will affect your answer, and that is why this 3 and this 3 are the same sub problem. So this is a repeating sub problem. So in this particular case, we have to return the same value as this 3 had returned, which is 1. So I will not be calculating it further, I will just be returning it back. So I will be returning 1. Now this 1 got 2 from by extending the string by zeros, and 1 by extending the string by 1. So it will be adding 1 and the total value will be 3. So this will be returning 3. So this is not a good string. Therefore it will not be adding 1 value, but after adding zeros, choosing to go with zeros, it got 3 good string. And if it starts to go with 1, then it will start with 1 1, right? So the string here will be starting with 1 1. Now at position 2, if you look at it, this is the same sub problem as this one, right? So this is a repeating sub problem. The return value here was 2, and therefore this can also return value 2. So it got 2, and so the total count of good string will be 5. So I hope you were able to understand this recursion tree diagram. If you choose not to go with saving the repeating sub problem, then in the worst case the 0 value can be inputted as 1, and the 1 value can be inputted as 1 as well, which is the size of the subarray for 0 and 1. And so the recursion tree diagram, which is a binary tree, will be a perfect binary tree. And you know that in a perfect binary tree, the number of nodes will be order of 2 to the power of height. And in this particular case, the height will be n, which is the length of the string, because at each height you will be choosing to actually include either the 0 number of zeros or 1 number of ones, right? So the height will be order of n, and therefore the total number of nodes in the perfect binary tree will be order of 2 to the power of n. And so if you solve it by recursion, the time complexity will be order of 2 to the power of n, and the space complexity will be order of n, which is the recursion call stack size, right? Now if you happen to save all the sub problems, then the total number of sub problems will be equals to order of length of string, which is, let's say, n. So since we are solving each sub problem only one time, therefore the time complexity will be order of n, and the space complexity will be order of n due to the recursion call stack, plus it will be due to the memoization table or the dynamic programming table that you take. For this particular example, you can make a DP table of size. How much will be the size? It will be equals to the length. So what length will we take? It will be equals to the high. Okay, so the high value is 3, so you can go for a 3 size, because anything beyond 3 size is not a valid good string, so I don't care about it. And so whenever you solve a problem, you just fill this table value by x, y, z, and whatever is the case, right? And which value will give you the result? The result will always be given by the 0, because in this particular case, if you take it as the DP table, then the DP at I if it is equals to x, this means that if you are at position equals to I, then from this position onwards, how many different good strings can you make in all possible combinations, right? So this entire problem was asking, given that your string is starting with an empty string, and you can choose to go with zeros and ones at any point of time, then how many good strings will you create? So the dp at 0 will give you the answer in this particular problem. So I hope you were able to understand this entire solution. The time complexity order of n and the space complexity is order of n for the DP solution. Let's now look at the code. If you are someone who is looking to prepare for top product based company within a limited time of just 3 months, then we have brought for you both the DSA and the system design live interview training program. The most important feature of this program is you get a filtered and condensed structured curriculum, in-depth discussion of all the topics, and my guarantee of your understanding, one-on-one guidance with me, and live weekend classes. To know more about the training, you can WhatsApp us on this given number. In this particular problem, I will be taking the DP table of size 10 to the power of 5 plus 1 because the maximum size was 10 to the power 5. And then it was said that since the count can be very large, therefore we need to take mod of 10 to the power 9 plus 7. So I'll take a mod variable for that. Now count of good string is the main function where we are given the low high value 0 and 1. So I'll be setting my DP table to a preset value of -1 because since it is a counting problem, the count cannot be negative. Therefore I'm just setting the DP table to an impossible value so that if -1 is the value in the DP table, that means it has not been calculated yet. But if it is something positive, then that means it has been calculated. The sub problem has been calculated and I don't need to calculate. I'll just return it back. So I will make the call to the count ways. So all the variables are same except for the position, which is additional. So currently what is the position is my sub problem. So if the position is greater than high, then this particular current string is definitely not going to be a good string, and any further processing is just useless for us. So I'll be returning 0. While if the DP at position is actually not equals to -1, this means it is already calculated. So just return the pre-calculated values. I will not be reprocessing the same sub problem. Otherwise, if it has not been processed, then I will be counting how many ways can we do that. So the first thing I will do is currently if the position is within the range of low and high, then I will be doing count plus plus because this is a valid string. But even though the string is valid within the range of low and high, if the string is valid, but still I can add some zeros and get another string which is valid, and I can add some ones and I will get another string which is still valid. So therefore I will be adding to the count whatever I can get by creating a new string, by adding zeros and by adding ones. And I will be trying to extend. So the total count will be taken with the mod function, and then we will be updating the answer for the particular sub problem so that if it occurs again, I don't have to recalculate it. So this is the entire code and I hope you were able to understand it. If you still have any doubt, then feel free to comment below and I'll try to help you as soon as possible. Like and share our video and subscribe to our channel in order to watch more of this programming videos. See you guys in the next video. Thank you.